Yeah, welcome again, guys. To these are day 10, if I'm not wrong. And today we're basically going to talk about cross-contract calls. So basically, what we can do in order to be able to invoke or execute functions in other smart contracts. So basically, invoking some functionalities or functions that are in external smart contracts, but within the near blockchain. So that is basically what we're going to cover today. If you do not have a project idea yet, I think time is now running up, and you may not be having all the time. So please settle on an idea and start working on them as soon as possible. So whatever you're going to do today is going to require all the tools we've needed for our previous sessions. So if you have all that, you're good to go. And what we'll cover today is basically writing a smart contract call. And let's get to it. Now, I'm going to share. Okay, just a minute. Awesome. Now, I'm going to share with us what we did in our previous sessions. That is the smart contracts we wrote in the previous sessions. And that is basically the wish list smart contract and the counter smart contract. So these are our counter smart contract. I really hope you remember all these, or rather what we did right here. So we have our counter structure, that is call it the entry structure into our smart contract, so the main one. And we have all the methods within our structure down here. So we had quite a number of methods. There's one that we did and was almost confusing you guys. That is staking, the concept of storage staking. But then I clarified that while doing the wish list smart contract, and I hope that idea was quite well understood. So in our counter smart contract, here are the methods we have. So some are private, some are public. Okay. Actually, all of them are public. Yeah, all of them are public. So the methods that are related to a counter are the increment, the decrement, and the read value. And they're also making use of these other methods down here. And then for this session, we're going to use the first three methods up here. Okay. So these first three methods, that is the save name, which is basically going to push a name to a smart contract. So basically storing a name to a smart contract. You realize it only requires a name as the only parameter. Then we're also going to make use of get names. So in this case, it is going to get the names that are currently in our smart contract or stored in the database of our smart contract. Then you can as well remove a name. That is the last argument from our smart contract. So these are the basic functions we're going to work with from our counter smart contract. Now, I'll just head on to I'll just head on to our wishlist smart contract. Can someone confirm if you can see this from your end? I'm sharing the wishlist smart contract where we have the wishlist structure. Are you guys able to see that? Maybe someone can confirm in the chat, please. Okay, thank you. So our wishlist smart contract basically had a wishlist lookup persistent collection that we're basically going to use to store our wish list against our wallet addresses. And here are the methods, or this is basically how it appeared. So this is the test module. And I kind of want to, oh God, I can't minimize that. Okay. I wanted to minimize it though. So here are the methods. So for the storage staking, here are the methods, private, and our main methods are here: add car, read wish list, and delete car. Okay. And this is already available in our wish list repo and a wish list branch.
I'd like to ask a question.
Yes.
For all the smart contracts we are going to write in future, are all of them going to have that storage staking bit?
Okay. It's we call them best practices. You can as well write a smart contract without that. Okay, it's not a must, but it's considered a best practice, because assume you're going to do a smart contract that is basically going to store some information, right?
Yes.
Then you're not going to charge users for this information they are going to store on your smart contract. It is very likely that someone can spoof your smart contract. So in this case, basically sending records for you to store. And if you run out of, because for every data you store in your smart contract, you have to stake some NEAR tokens for it. Now, if I send you like 10 GB of data and you use all your NEAR tokens that is within your smart contract, then your smart contract will no longer function.
Yes. Something else. Is it something we can copy paste, or for each contract that storage staking code is going to be different?
No, as long as you understand the concept, you can implement it in any way you want, as long as you do it right. Yeah. Though we have a standard, we are having some standards. I don't know if I can just get these. There are some standards. I'll be sharing with us a link to read more on that. But there's something.
Sure. Okay.
So now today we're going to talk about cross-contract calls, and like I said, in our previous sessions, there's somewhere we sort of covered promises. I really never talked about intensively about them. So today, what we're going to do is basically we're going to sort of use promises for the better part of this session today. And promises are basically it's a way that is going to help us execute a certain task in the future. So in blockchain, let's say we wanted to execute a method or a function from a different smart contract, right? Now, the reason why we are using promises to do this is the smart contract could be in a different shard. Okay, so it basically could be in a different shard. A shard is basically like I told you, execution on NEAR blockchain runs parallel. Okay, so while yours is running in a different thread, this is the layman explanation I can give. So assume that your smart contract is running on one thread, and the smart contract you're trying to call from your smart contract is also running in a different thread. Now, this way, for these two smart contracts to communicate, there's something they're going to make use of, and that is what we call or refer to as receipts. So receipt is what is going to basically map the transactions within the NEAR blockchain. Now, when you invoke a cross-contract call to a different smart contract, there's a receipt, sort of an ID that is generated that will be able, will facilitate the invocation of the method you're trying to call in that other smart contract. And that way, you're able to bundle execution, code executions for future execution. So this way we are able to wait. It's just like the promises in JavaScript. If you're familiar with JavaScript, you can just invoke a promise, then you await for the response once the response is ready, right? So that's why you usually have a .then method somewhere. So whenever the response is going to be ready anytime in the future, there's a method that is already in place to get the response. Okay, so that is what you're going to achieve at this point. Now, I'm just going to add one method actually in our smart contract, And this method is basically going to help us call a method that is going to be in our counter smart contract. Okay. Now, let me just head on to my wishlist smart contract first. Now, there are some very few things we need to put in place before we proceed. And the very first one is going to be, we're going to use a macro that is going to indicate, we're going to avail a trait that is sort of going to give us an interface of the external smart contract we are trying to call. Okay. So the very first thing we need in place is a public trait. We're going to call this public trait counter. So this is basically the method we are trying to call, the external smart contract we are trying to call. And in this external smart contract we are trying to call, it has a method called save name. Okay, so I'll just copy it as it is. That is basically the method name. So the save name method is returning a string after its execution. So you really need to take note of that. So I'll just come here and say function, and that is the function name. Our function accepts, maybe if I can get here again, a mutable self. Let me just copy the parameters as they are and paste them right there. A mutable self. Then it's going to return a string once we invoke it. Now, since this is a trait, we're not going to implement this function within the trait. Okay, we're going to implement it in the structure, in this case, a class that is going to implement this particular trait or interface. And like I said, there's a macro that we have to use for us to indicate that this is an external contract. Okay, and there we go. So this is an external contract, and we're going to call this contract counter. So we can call this external, external counter or ext counter. Now, while we're going to compile this particular smart contract, it is going to, it should be counter, sorry. It is going to convert using this macro, that is, it is going to convert this trait into a module. And that module is going to have a method or a function by the name save name. And then it's going to do some magic behind that. Now, maybe I should just mention before we proceed that I'm going to use a high level implementation of a cross contract calls, but then we have medium level and low level. Okay. So if you're going to be very serious with this, you can do some research on how to implement a medium level and a low level cross contract call. So low level is going to have some very you're going to use some low-level functions that NIA is going to avail to you to be able to achieve the same functionality we're going to do with these high level. Now, that is the trait that you're going to use to sort of call our external smart contract. Then we may want, okay, let me just, let me not introduce that right now. I may confuse some of us. So right in my implementation, or where we're implementing the wish list, methods, we're going to have a public function, and this public function, we're going to call it cross contract call to our counter smart contract. And let's just have the function in place first. Then we're going to have a function that is basically, okay, first of all, we need to define some constants or avail some values that we're going to use for us to be able to achieve these without any struggle. So we're going to have a constants variables in place that are going to hold values to the gas that we're going to spend to invoke these functions. Now, the first value of gas you're going to need is the one we're going to use to invoke the save name smart contract, the save name method of the counter smart contract. So in this case, we're going to refer to it as counter cross contract call. And we're going to assign these, let's assign it seven teragas, that is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So basically, those are 12 zeros, right? And this one is going to be of type gas. It is gonna be of type gas. Just have this one formatted. Okay. We should just use the normal data types we've been using. Okay, so that is the value of gas you're going to spend to call the cross contract method. Then the other value you're going to need is the deposit. So if the method we're going to call is going to need any sort of deposit, we also need to explicitly define that. So this will be counter deposit. And this is basically going to be 0. This should be of type U64. Yes, so that is counter deposit. This should be U64. Yeah, so everything we need is in place. But there's one thing that we still need to avail, and that is the smart contract account ID. Now, the external smart contract we're going to call has been deployed to a wallet address somewhere. Okay, so like in our case, we have this. We deployed this to, let me see. So here's our deploy script. And this was deployed to test.wajakoya.testnet. So this is what we're going to need, because we have to point our call to a wallet address where the smart contract was deployed. Okay, so that is what I've just copied, and we're going to avail a function that is basically going to help us avail this value. So we can have this as a private function, and let's name it counter account ID. Counter account ID. So this one is going to return a string that is basically going to give us the wallet address where the counter smart contract was deployed. So it should be something like that. Sorry, yeah, that. Now, I think we have all we need in place. So let's implement our cross-contract counter method. And these, for us to be able to achieve this, we're going to have to use this module that is now, like I said, once you're going to compile this code, this public trait counter is going to be bundled or translated into a module. The module is going to take the name we've provided up here, ext underscore counter, and it's going to have a method that is going to have a name, save name. So in our method, we're going to assume that all that has happened. So we're going to just use the module that will be created. And from that module, we're going to invoke the method. We realize it's even in place already, save name. And our save name is going to take a parameter, right? So the parameter that is going to take is of type string, and that is the name. So we can just provide, let's just provide that right here. So we can just provide the parameter name over there. Then the next thing we're going to need is the account ID. okay? Account ID of the smart contract that we want to invoke this function on. Now, that is going to be self. Let me just provide these as well here to qualify these as a method of this class. Then right here, we're going to have self dot counter account ID. Account ID. Yeah. This one should be a reference. Should be a reference to that. Then we're going to need, okay, this seems to not be working. Mismatch types, found struct. Okay, let's first proceed. So the other thing we're going to need is balance. So this is basically the deposit you're going to attach to this particular call. And like I said, this method doesn't need any attached near token. So we're basically going to provide 0 that way. And then we're going to provide the gas that we're going to use. Let's have this gas. So counter cross contract call gas. And let's have the value put right there. Now, having this in place, let's first return a promise. So basically a value that is going to be returned to us. Okay. So in this case, we're basically returning a promise. And I can see there are some errors right here. You can convert these. Oh, so these should be of type U128. Yeah. Then our gas should take, let's see the data type that is suggested, expected this, but then it found that. So these should take U64. I think that should be the data type for our gas. Yeah, something like that. Then our counter is also complaining. The method counter ID found for reference in the current scope. Okay. So let this guy also take this first parameter to qualify it as a class method. Now, everything is working great. I really hope you guys can see this. I hope it's now a bit clear. Now, this is what we put in place. So we basically, by invoking this save name method, we're going to return a promise. So for now, we're not going to handle any callback. We just want to see how this is going to behave once deployed on the blockchain, okay? And we're now going to call this method passing in the name that we want to store in our counter smart contract, okay? So you realize the name you're going to store, we're not storing it in our smart contract, so in our wish list smart contract, but we're going to store it in the counter smart contract I've just showed us. Now, let's have a look at the scripts. So we're basically going to first of all build this smart contract, then deploy it to our account ID as was provided right here. And finally, we're going to call, so in this case, we're going to call our wish list smart contract. So let's first of all build this. So first of all, build this. sorry, I think I was talking while muted. So I said we are deploying, we're now deploying the smart contract to the blockchain. So while that happens, let me just write the function we're going to call. And at this point, you're going, now this one is going to be a cross contract call for save name in, we are saving this name in test.wajakoya.testnet. So this method we're going to call is living in test.wajakoya.testnet wallet address. So near call that. So deployment was successful, guys, as you can see down here. So the function name we're going to call is X cross contract call for counter smart contract. So that is going to be the name. We need a parameter, in this case name, and we're going to provide that is the value. Let's use Alan today. I hope Alan, you don't mind. Then we're going to specify gas. Now, I really want to mention something here about gas. You're going to really be frustrated while doing this on your own if you don't take keen note on the amount of gas you're going to attach to this particular smart contract, because you realize we've specified 7 teragas for the cross contract call right here, right? So just for us to be on the safer side, let's double that while doing this invocation. So I'll just do 14 and then 12 zeros like that. And once we have this in place, we should be able to run this. And guys, maybe let me just take us back right here. This is our counter smart contract. So you realize once we save the name, we are returning the value we passed as our return value, okay? So in this case, we're going to pass Alan. So Alan is going to be pushed to our names database or persistent collection. Then we're going to return the same value we passed here. So that is Alan. Now, we expect that once we run this particular command, we expect to see Alan printed in our terminal. So that value will come from test.wajakoya.testnet and not our wishlist.polotieno.testnet. Okay. So that is where the catch is. I really want you to be keen while we do this so that you don't get confused. I really hope this is going to work. Let's see though. Let's find out. Awesome. So guys, the smart contract went ahead and invoked the save name in test.wajakoya.testnet. It saved the name, then it returned or responded with the value Alan. And that is what we printed, or what was printed in our terminal over here. Okay. So that is the value. I really hope that is fine up to there. Up to that point. Now, assume that this value returned to us. We wanted to do some sort of, we wanted to do something with it before actually terminating this execution on our end. Okay, so think of it like you're sending a HTTP request to an API in a different server. The API is going to respond with some data to your server, and then you want to process the data returned to you further, okay, within your server. So think of it like you're coming up with a weather app, but then there's already an API somewhere that deals with these data, the weather data. So you're just sending a request to them of a weather of a given area, then it will respond to you with, let's say, humidity, temperature, and all that, pressure. Then using this data, you can now further process it within your application. So you can either decide to display it, or you can either decide to store it within your application. So whatever you want to do with it within your application. Okay, so that is the concept we're now going to look at now. So like I said, our cross contract call just passed. So let's see how we can handle callbacks. So in this case, if you're coming from a JavaScript background, you realize there's after a promise, there's this famous method .then, and inside .then you can further process whatever the function is going to give back to you. And at this point, I'm going to introduce what I actually preempted while I was beginning this session, and that is we're going to come up with another trait, but then this time round, this trait is going to be called within our smart contract. Okay, so it's not going to call an external smart contract like the case right here, but it's going to call a method within our smart contract. So let's have it as a public trait. Let's call it self. Okay, self is a keyword already, so we can use something else. AXT self, something like that. Then within this trait, we're going to avail our callback function or our callback method, the method we are going to use to further process the value that is going to be returned to us. So let's call these, let's call it callback or response callback. Just as simple as that. So response callback is going to be a function, and let's have it also return a value. So in this case, it can return a string, though it's not a must that it returns something, guys. But you can decide to have it return something. So it's going to be a mute self, and it will be accepting. So this function is going to accept the response that is going to be returned to us after saving a name. So in this case, it's going to be a string, right? So we can simply say we are going to accept a name, and it's going to be of type string, right? So that is basically what we'll need in place. And we also need to have it take a macro, so the external contract macro. However, this time round, we're going to provide a very unique name just for this. So it's going to be, so the module that is going to be realized after bundling all these is going to be a ext self. It's going to take the name ext self, and it's going to have this method within it. Okay. Now, maybe something to point out, you realize in our counter trait, our method was accepting the usual self parameter and then the name. However, when it came to the implementation, there are some extra things we accepted. So that was the account ID, the balance, and the counter gas, or the gas we're going to spend. Now, like I said, this is going to be converted to a module. And while that is going to happen, it is going to add some default data types, or sorry, some default parameters that are going to be required for you to successfully invoke this method in the external smart contract. And that is the account ID where the smart contract was deployed, the external smart contract is deployed, the attached deposit, which in this case is 0, and the gas you're going to expend, or you're going to attach to this particular function call to that smart contract.
Hapo sana.
Alan? Okay, thank you. Yeah, so sorry guys for that. Yeah, so that is it. Now, it is what we're going to do with our callback is going to take the same function or functionality or appearance. Okay. So right here we have our module in place and the function. So let's implement this function within our smart contract, because it is basically going to take the response after doing the function call. And it's always advised that you keep this a private function. And how do we do that? You avail the private macro. So after availing the private macro, even if you start your function with the pub keyword, it will still be invoked within, it will near in some way is going to force it to be a private function within your smart contract. So you won't be able to call this outside your function. So that is the name it is going to take. Then we're going to have it take a mute self. Then we're going to have a name. So at this point, okay, let me just have this in place first. So this is basically the response we're going to get after executing the save name method on the external smart contract. However, there's also another macro that we need to use for us to be able to capture this response well within our function, and it's called the callback. Okay, that is the callback function. So our function is going to return something of type string and year. So this is basically it. So we expect this name parameter. Now within our smart contract, like I said, after getting this response from the external smart contract, you can make use of it the way you want, right? So you can either process it further or do something else with it before returning it, okay? And like I said, you also, it's not a must that you return the same value as well. So at this point, we're just going to, let's make another string. We're going to call it results. And we're going to make a string from whatever was returned to us. So in this case, the name. That is the name that was returned to us after executing that. Then we're going to push another string to that, but just to indicate that this was processed first within our smart contract before it was returned to us. Okay, so we're just going to put a space, and then we're going to indicate here that processed in wish list smart contract. Okay, so we're going to have a value, in this case a string, that is going to be returned to us after executing the save name method. So we're going to basically concatenate this string, and we're going to add another string to it. So basically appending another string to it. And then after doing this, okay, let's qualify this to be a string. That should work. We're basically going to do what? Return the result. Okay. So yeah, that way. Oh, these should be push str. Yeah, that should be push str. Then it should be all this thing. That is now working. Come on. Oh, I need to have these as mutable. Keep forgetting these. Yeah, so yeah, that should work. Then after processing the callback we receive, we're basically going to do what? Return it. Okay, so that is how we do that. We're basically going to return that back to the user. Okay, now let's do this. In our save name promise, guys, I said whatever is going to be returned there is going to be a promise. Let's invoke, let's handle the response that is going to be returned to us. So in this case, we're going to avail a dot then. Okay. I hope you saw that. A dot. Okay, let me do this. A dot then, that is the method. So you realize there's this good illustration over here, a pop-up. So you do a promise.new, something, and you create account. So this is basically giving us sort of scenarios where you can use the promise as well. And then down here, there's a dot then. So we're handling the response. We're handling the callback. Sorry, we're making use of our callback. So we are handling the response that was sent back after invocation of that particular promise. So let's have a dot then over here. And then within this dot then, we're going to execute a method which is going to be availed inside our external self module right there. So ext self. And in our ext self, we're going to have a method by the name response callback, just like that. Then our response callback is going to take a name. Account ID in this case is going to be, let's see. Account ID is going to be in this case, the account ID where our wish list smart contract is going to be deployed. And how do we get that? We use the env module and we invoke the current account ID method for us to be able to get that. In this case, we're going to use a reference to that. Then our balance, we don't need to attach anything here, right? So we can just make use. Okay, let me just avail another set of records so that we have some distinctions here. So this is going to be wish list. This is going to be wish list gas, and this is going to be wish list deposit. So wish list gas, let's give it 5. Then wish list deposit can remain as it is, 0, right? Because you don't need to avail any balance over there. Then right here, we're going to avail the wish list deposit. Then after that, we need wish list gas, just like that. Aha, good. Now, do we need to provide this name? No. Why? Because this is going to come back from our, after executing that, after executing the function, the save name function. Okay. So let me just see if this is going to. Let me just confirm something here. Just a bit, because it shouldn't accept a value. Yeah, I shouldn't accept a parameter, the name parameter. That is going to be captured by our callback macro within our callback, our response function. Okay. So right here, we don't need to explicitly define these at the top. So we just need to leave it as that, because we are making use of this macro to capture that particular record that is going to be returned to us as the response. Okay. Now, everything is in place. So again, we're going to build this smart contract, deploy, and try and run and see what's going to be displayed, rather returned to us. So you realize at this point, we are still returning a promise. So we expect to see this value. Okay, so in this case, a name we're going to pass and this string appended to it. So let's just go ahead and try this out. So the very first thing we're going to do is build. So let's build our smart contract first. And again, I'm having unused import within my smart contract. Let me see what that is. I think it's gas. That was gas. However, I needed the callback, the callback macro in there. So yeah, so let's just build this after making all the changes, all the change I just made. Let's go ahead and build this and see what's how this is going to behave now. So let's rebuild this again. Awesome, so that was done. Then we're going to deploy. So we do the deploy again. Awesome, come on. Okay. Awesome, so that was done. So we just deployed it or redeployed it. And now let's do a call and see what string is going to be returned, or we're going to have an error. Great. So we're having an error, and it's telling us that the transaction this, so it failed. And in this case, we exceeded the prepaid gas. Okay. So we need to check the amount of gas we attached to this particular transaction, because if you're actually going to practice this, you're going to face a lot of this error from your end. If you're not going to take keynote on the amount of gas you attach. So let me just change this to 140 teragas. This is just for demo purposes, guys. This is just for demo purposes. If this is not going to work, then we'll have to make some tweaks in our smart contract. Awesome. So you realize that just worked. So it means that we attached less gas than what was required. So at this point, whatever was returned to us was Alan, and then this string processed in wishlist smart contract over there. So it was accepted within our smart contract in our callback function, and then it was further processed. So the response was further processed, and finally the final result was displayed to us in the terminal. Now, if I can just sort of change this particular name. So let's use another name. Let me see who I should use today. Jeremic. Let me use Jeremic. So let's pass the name Jeremic right there. Then just rerun our smart contract function. So this, you realize it returns Jeremic and then processed in wishlist, and yeah, all that. Now, these names, we expect them to be stored in our counter smart contract, right? Now, I'm just going to invoke a function from our counter smart contract to see if actually these functions are in our counter smart contract, because they should be there anyway. We are storing them. So if you can just have a look at this, the save name method of the counter smart contract is saving them in the names lookup map. So let's just try and call, what was that method again? Let me see, get names, right? So these should be get names. We can just see that somewhere, please. Get names over here. So I just uncommented that. So this is what we're going to call. This is going to be scripts / call. Oh, sorry, call. Yeah, so you realize we have Alan Alan, because we keyed in that value twice. Then we have Jeremy. Okay. Now, guys, we are running this direct in testnet.wajakaya.testnet in test.wajakaya.testnet account. So in our counter smart contract. Okay. So I just ran these in our counter smart contract, which was deployed at that wallet address. And I invoked the get name function, and it displayed what we have right here. Now, if I can just get back to our wishlist smart contract, then try and invoke the cross contract again, but then with a different name this time round. We can call these Philip. So if I try to call these again, I expect to see that value from our counter smart contract. So if I try to invoke or get the names in our counter smart contract, they should be able to give me. I think I'm having slow internet. So I have these. Oh God. Okay, yeah. So yeah, my internet is a bit unstable, but that went through. So Philip was returned. Now, if we head back to our counter, now we should expect to see Philip also. So that is it. Okay. So guys, that is basically it about cross contract calls in Rust. You realize the concept is really simple, right? That is quite simple. Is there any question from anyone? Any question from anyone based on the cross contract call concept? Hello. So I hope we are good to go. I hope you've understood this. I'll be pushing these I'll be adding this change in our wishlist app branch of our wishlist repo. So please, just in case you want to do some feature reference, you can just go ahead and do the reference of the repo. Yes, Destiny?
Hello, sir.
Hello?
Okay, can you hear me, sir?
Yeah, I can get you.
Okay. Sorry, I didn't join the class on time because it has been raining here and I just got a little break from the rain now and I had to come outside where there's network to join the meeting. It was 90 minutes late. So I don't know the purpose of this meeting and the kind of smart contract we brought to this. I would like you to rewind on it, please. Like,
So
what kind of smart contract do you write? What's the purpose and so on and so forth?
okay, so maybe you can let us know where you found us. At what point did you join us? Destiny?
Hello, sir.
Yeah.
Okay. I met you while you were writing. Okay, I can say I remember that place where you were writing the deposit and the withdraw. Deposit and the withdraw.
Deposit and withdraw.
Deposit and withdraw, and you assign 7000000 to 1 and 0.
Okay.
To the withdrawal.
So okay, today we're talking about cross. Yes.
Yeah, I'm listening, sir. I'm listening, sir.
Okay, I was saying today we're talking about cross contract calls concept in the NIA blockchain, and I said so. I think you found us somewhere here. So right here we were just sort of availing some values we're going to make use of within our code, and from line 33 to line 36, we were availing a trait that is basically going to help come up with a module, in this case, the external counter contract module with the save name method in it. And like I said, guys, there's a link I'm going to share with you where you can read more about this. So if you're going to tackle the medium and the low level, cross contract concepts, you're going to understand actually what's going on under the hood. But like I said, we're covering the high level concept. So right here, there's something that is still going to, there's a way this code is going to be structured in the background, and we're going to generate a module. This module is going to take the name ext counter, and inside that module, you're going to have a function called save name. And the function is going to take, or there are some 3 other parameters that are going to be added in this function. So basically, the address of the smart contract we are trying to call, the deposit, if any, that we want to attach to that call, and the amount of gas you're attaching for that particular call. Then after invoking the external function, so that is the function we are going to invoke in the external smart contract, if the function is going to respond or return some value, we can as well process that value further within our smart contract. And what is going to help us achieve that is this ext solve trait, which also in the background is going to be structured or processed further. So we're going to generate a module out of this, and the module is going to take the name ext solve. And within that module, there's going to be a function, response callback. And this is also going to take some, we're going to add, there are some 3 other parameters that are automatically going to be added, just like the save name method up there. And these are going to be the account ID. So in this case, the account ID is going to be for our wishlist smart contract, because this function is going to be expected to be executed within our smart contract and not externally. Then the amount of deposit, if any, that is going to be attached to it, and then the gas unit. So that is basically what we did up here. Now, in the implementation of our wishlist smart contract, we added 3 methods. So this is the counter ID method. So this is basically returning the wallet address where we deployed the counter smart contract. So basically the address, that is what the method is doing. And the XCC counter, so the cross contract call counter method, is where we're going to actually invoke the cross contract call. So like I said, the ext counter is going to be a module that will be generated. And in the module, you're going to have a function, save name, which in this case is going to accept a value name or a parameter name. And then there are these other, if you can see my screen, there are these other parameters that were added automatically while the module was being generated. And the first one was the account ID, the balance, and then the gas. The account ID is taking the wallet address where the external smart contract was deployed. So in our case, where the counter smart contract was deployed, and we get that using this method down here. Then we key in the balance. So in this case, if there's any near tokens we want to attach. So in this case, we're using counter deposit, which is just taking the value 0 up here. And then we are passing in the counter cross contract gas, which in this case is taking 7 teragas. So 7 and 12 zeros behind or after it. Okay. So by invoking these and without a semicolon after these, let me just comment these out first. So by invoking these line 119 without a semicolon after it, it means we are returning the value. And the value in this case that is going to be generated with this statement is going to be of type promise. So that is basically what we indicate as our return type right there. Okay. Now, if we are just invoking the cross contract, the function call, but then there's nothing else we want to do with whatever response that is going to be returned to us, then we can just leave our cross contract call at that point. However, if we are looking to processing that value further within our function, then we'll have to make use of the then method of our promise. So this is basically going to handle the callback. Okay. And passing, so the dot then method is going to take the method of the ext self module that is also going to be generated from this statement right there. So our ext self module is going to have a method response callback. Then this response callback is basically going to take an account ID. So you realize our response callback trait over here only took a mutable self as the parameters. Okay. So this is basically the default first parameter, because we're going to implement this within our smart contract, the wishlist smart contract. So down here, it is just taking the 3 parameters that were automatically added while generating the module, and that is the account ID. So in this case, we are going to expect this method to be available within our smart contract. So in this case, the current account ID where this smart contract is going to be deployed. And we get that value by invoking env semicolon, sorry, full colon current account ID. Okay, so the env module is going to help us achieve that. Then we specify the amount of tokens or near tokens we want to attach. So in this case, 0, that is the wish list deposit up here, basically 0. Then after that, we provide the wish list cross contract gas. So basically the value of gas we're going to pass for that particular operation. Now, if there's any, at this point you realize we also don't have a semicolon after all the statement. So if I just went ahead and put it accidentally, it would raise an error. Why? Because we are returning a promise. Okay. So let me just remove that. So by removing that, it returns all a promise. That is what is going to be generated after that. And we'll be able to display a value that is going to be returned by our response callback function. Now, we're implementing our response callback function right here as a private function within our smart contract. And it is taking the self parameter. So this basically qualifies it as a method of this structure. Then there's this parameter I availed right here. You realize I didn't capture it while defining this in our trait. Okay, because this is the value we're going to capture from the response that is going to be returned to us after invoking the save name method in our external smart contract. So whatever value is going to be returned, in this case, we expect the function to return a string. We're going to capture that, and this macro is going to help us do that in a high level representation. Then we're going to store that value in this name parameter. And inside the callback, the response callback function or method, we basically, processing it further or showing how you can process the value further. So inside here, you can do as you wish. So in order to show how we can process the name further, I just went ahead and made a string. Then I appended or concatenated it with another string. So in this case, processed in wishlist smart contract. Then I basically returned the resultant string after processing the name string that was returned to us after invocation of the save name method of our external smart contract. So that is basically what we've done. And running this in our terminal. So that is our call script over here. So we basically went ahead and ran the command near call, passing in. So this is where we deployed our smart contract. So the name is right here, wishlist.paul.testnet. And the method name we are trying to call in this case is cross contract counter. So XCC underscore counter. So this method, because this is where we're implementing our cross contract logic. Then we're passing in the name parameter, giving it the value Philip. So it's accepting a name parameter right here. And you're giving that a value of Philip. Then you're basically signing this particular transaction and giving it a gas value. So in this case, we gave it 140 teragas value. So if I can just maybe can just change the value right here to Destiny. Oh, sorry, Destiny. Now, if I go ahead and run this again, Destiny, we expect a name or a string returned to us, that is Destiny, and processed in wish list smart contract, something like that. Awesome. So this is what I was talking about. So we have Destiny processed in wish list smart contract. And if we go back to our counter smart contract, that is where we are invoking, we are retrieving the names that have been stored in the test.wajakoya.testnet smart contract. We should expect to see the name Destiny added to the list. So as you can see it over there. So that is basically the concept of a cross contract calls between smart contracts. So basically smart contracts can communicate between themselves, just like the Web2 backends communicate with one another through the API system, the HTTP API system. So in the NIA protocol blockchain, this is how smart contracts can as well communicate or cooperate in achieving certain tasks. So I don't know if that was clear, Destiny, from your end.
I can understand the concept now. Like,
Okay.
It's contract calling another contract.
Yeah.
So I think one contract bringing data from the other contract to its contract. I really need the terminal in the near protocol.
Okay. That's
Is that correct?
Yeah.
I will watch the video once it's uploaded. Major this area that you explained it to me personally. Contact number. If I have any other question,
Okay. That's awesome. So guys, is there anyone with any other question? Maybe before we call this a session. Let me welcome Jeremy Eros to just greet us today before we call it a session. So Jeremy, please welcome.
Hello guys.
Hello.
Hello. Yeah, I'm pleased to be here. I've been following since last month. Yes.
Okay. Wow.
Yeah.
So you were there while you were talking about assembly script.
Yes, I was there.
Wow, that's awesome.
Okay, thank you.
Have you started working on your project, or you're done already?
Yes. No. I shift to learn Rust, so that's why I just paused in order to understand Rust first.
Okay.
Yeah.
That's awesome. Thank you so much.
Thank you.
Great. So yeah, guys, that is it about the cross contract calls. So let me just stop recording this first before you proceed.